we have one question. Let me read it. Is it true that CLOB stores data in the database character set, but if the database character set is Unicode, then the CLOB stores each character in 2 bytes? And if yes, then why is this difference? Okay, so let me answer this question. So this CLOB is stored either in the database character set if the database character set is single byte, or it is stored in AL16 UTF-16 if the character set is multibyte. And by multibyte, we include AL32 UTF-8 as well, which is multibyte, obviously, 1 to 4 bytes per character. So as it is multibyte, then CLOBs are stored in AL16 UTF-16, but this is also the case if the character set is JA16 SGs or any other multibyte character set. And the reason for this storage is that CLOB APIs, most probably following SQL standard, but I have never verified this, are defined in terms of characters, not bytes. So if you look at the APIs, the DBMS underscore LOB package, or the OCI LOB functions, then you will see that offsets and the length of data that is to be written or read is specified in characters, not bytes. And of course, because CLOB may be very large, up to 128 terabytes, if I remember correctly, then finding whatever millionth or 2 millionth character in a value that is stored in a variable width character set, multibyte variable width character set like AL32 UTF-8 would be very expensive because you have no idea at which byte a given character starts if the storage character set is variable width, because you don't know what characters are before this character that you are looking for, which means that you would have to actually read all characters one after another, checking their length. I mean, not checking their length, but actually like skipping them one after another until you get to the character at offset 2000 characters or whatever. So to avoid this extremely expensive implementation, the decision was made to store data in AL16 UTF-16, which is the Oracle implementation of the UTF-16 encoding. And here is actually a little cheating, right? Because UTF-16 is not really fixed width. For characters in the basic multilingual plane, so all Unicode characters with code points below 64K, the storage is indeed fixed byte. So you need 2 bytes per character. However, for supplementary Unicode characters, they are less frequently used, but still they are used. You actually need 2 UTF-16 code points, a high surrogate and a low surrogate. So if you really talk in terms of characters, then some of the characters will occupy 2 UTF-16 code points, which means this is not really a fixed width character set if you consider not code units, not UTF-16 2-byte code units, but the actual characters that get encoded. So in Oracle, because there is no good solution for it, again, we would have to store the data actually in UTF-32 to have a really fixed width encoding, and this would be prohibitively expensive as far as storage is concerned, because even for ASCII characters, you would need 4 bytes, which is obviously a terrible way of using storage. It would be very wasteful. So it's more or less the LOB APIs work well for most characters, most popular characters which belong to the BMP plane. However, if you actually store supplementary characters, you need to remember that you don't really get the whatever millionth character, even if this is documented, but you actually get the millionth UTF-16 code unit. So if there were no supplementary characters stored before the character number million, then you really get the millionth character. However, if there were some supplementary characters stored, for example, all of them were supplementary, then each of them would occupy 2 AL16 UTF-16 code units, which means that you actually arrive at, if you get the millionth character or the offset is million in the DBMS LOB or other LOB API, you actually get the character 500,000, because if all of them were supplementary, then each of them occupied 2 UTF-16 positions. So it's kind of complicated, but this is the unfortunate result of how data is stored and how Unicode is built. And because we have so many characters, either we waste storage or we need some extra processing time. So this is kind of we are in the middle, right? So it's kind of character based, but not 100%. So as long as you don't use supplementary characters, fine. If you use supplementary characters, then it's not fine. Then you have to kind of somehow account for it in an application, and then it strongly depends on the application what's the actual requirement here. I hope it answered the question. If you need some more explanation, then please ask. This is not well documented. I must admit we should improve the DBMS LOB documentation to discuss it a bit. So the follow-up question is, so this essentially means that CLOB favorizes processing time, while varchar 2 favorizes storage minimization. So actually it's not really this way. Varchar 2, actually the assumption is that varchar 2 is small enough for like when you need, because when you arrive at a given offset in a varchar 2 value using, for example, the substring function, right? You have exactly the same problem. You have to count the bytes. However, the assumption is that varchar 2 values are small enough for making this skipping of characters to get to the right offset cheap enough. So if we have a multi-byte characters, a multi-byte variable with database character set, we can actually skip those characters, because actually we in most cases we will read the whole value into a buffer anyway, right? Before any processing is done on SQL, even if it is a 32K value. So the maximum length that you can get to. Still, the whole value is read into a buffer before any processing is applied on it. So this is already a memory operation, and we have, of course, an optimized algorithms, especially for AL32 UTF-8, to skip over characters. So it's not that expensive. However, as I said, CLOB can be up to 128 terabytes, right? So you don't want to read, if you want to get at the end of the CLOB, right, or whatever number of characters, you don't want to read the whole thing, because you may have to read the whole disk to get to this offset. And of course, you have the indexes at the byte level. You can get to a block that has a given byte offset, but you don't have it for characters. We don't have this extra structure that would provide such mapping. So basically, it's not even favorizing. It's like making usable, right? It's you cannot if you do a storage in varchar 2. Sorry, if you store CLOBs in a variable with database character set, it would be prohibitively difficult word. It would be prohibitive to really process it character-wise, right? So the only way would be actually to redefine the CLOB APIs in terms of bytes, but this is again not very useful for anybody because what does it mean byte million, right? If the storage is in characters, if this is a CLOB, a character lob, then you want characters, you don't want bytes. Blob is fine. With blobs, you have the APIs are defined in bytes, and you don't have this problem. With CLOBs, they are character-based values, so you want to get to the given character. So so it would be nice to actually have CLOBs stored in variable with encoding as well, right? Actually, you need to remember that it depends on the language, right? Of course, for English, for English, the storage is much more. I mean, it's twice the storage, right? If you store in UTF-16. However, for example, for Hebrew, it's exactly the same 2 bytes, right? AL32 UTF-8 Hebrew character is 2 bytes, and UTF-16 character is 2 bytes. For Chinese, it's even cheaper. A Chinese character in AL32 UTF-8 needs 3 bytes. In UTF-16, it just needs 2 bytes, right? So it's actually cheaper, right? So you cannot even say that we favorize anything, because it also strongly depends on the language. Okay. So I have answered this question. I don't know if we have any further questions at the moment. Okay, we don't have any more participants, so I guess we won't get more questions. So I just want to mention what 2 new features we have in DMU 19.1. We have shown them during Open World. So the one is automatic character set detection, right? So this is a statistical use of, actually this is a use of the technology that we already have for some time in Oracle. However, it was only available through a command line utility that was provided together with Oracle database, and which allowed to scan text files to kind of try to guess what's the language and the character set of the given file. This is using machine learning. Actually, it's just a statistical analysis that was based on machine learning analysis of some input text, and we can now use this statistics that we have on various byte sequences that are common for given combination of the character set in language, and by comparing the frequencies of those sequences in the file, we can kind of guess with various probability what's the character set and language of the given file. Because we are not really interested in languages in DMU, we are interested in character sets, because the tool is about character set migration to Unicode. So we have used this existing technology to scan the column data so that we can try to guess what is the character set of the data in a given column. The previous, or the standard approach that the DMU does when scanning for conversion problems is to simply try conversion to Unicode and see if the conversion can be performed successfully without encountering any bytes in the source database that have no interpretation, right? So this is about the invalid representation issue that DMU discovers. However, this is a kind of dumb conversion, right? So we have seen a lot of, for example, Arabic databases. So I mean databases used by Arabic customers that were defined for some historical reasons as WE8 ISO 8859 P1. However, the data stored inside was actually in AR8 ISO 8859 P6, which is the Arabic ISO code page or the Windows code page. The problem is that, of course, because this is a single byte character set, this either Western European characters in WE8 code pages or the Arabic characters in AR8 code pages are encoded using the same bytes with codes above 160, basically, in this ISO 8859 code pages. There are not that many Arabic letters. There is no uppercase, lowercase distinction, so there are actually, I think, less than Latin letters. So it's enough codes available, and all the codes that are used by Arabic letters are some of the codes that are well defined in the WE8 ISO 8859 P1, which means if you try conversion from WE8 ISO to Unicode, and there are Arabic codes actually stored. I mean, what are stored are simply bytes, right? So that if the application interprets the same bytes as Arabic, but the database is declared as WE8, it's still, the DMU will think that everything is fine, because each of the bytes that is used for an Arabic letter has some interpretation in the Western European code page, because actually Western European code page uses more bytes than the Arabic code page, not less. Which means that if you have Arabic data stored using the pass-through configuration in a Western European database, then DMU won't discover any issue, because the conversion is successful. However, of course, after such conversion, the data inside the database will not be correctly encoded, because what will be in the Unicode encoding will be the Unicode encoding of the Western European letters that corresponded to the given bytes in the database, not the Arabic letters that corresponded to the exactly same bytes, however, with the different interpretation of AR8. ISO 8859 P6. And of course, we have this mechanism of the assumed database character set or assumed column character set, where you can declare a column or the database as storing something different than what is declared at the database level. However, you need first to know that you should mark a column with this different character set. So now this new feature that we have provided kind of help you with it. If you cannot get this information from the simply analyzing the system and knowing what are your clients, you can get to this information by simply knowing what your application does. You know that Arabic is entered and stored in the database, and you know that the database is declared as WE8. Then you can guess that you have the pass-through scenario, and you need to identify the character set of this Arabic data and label it appropriately for DMU to do the conversion. The new feature allows you to run a statistical analysis of a column and show, and the tool will show you with probabilities, various probabilities, what he thinks is the character set in the column. And this can help you in case your external analysis of the system does not really indicate what is the possible character set of the data in the database. Currently, there are some restrictions to the feature. I mean, the main restriction is that the feature is implemented in the client, which means when we analyze the content of the column, we have to read it from the database on the client using JDBC, which is obviously not the fastest way you can do this. We would like to build this functionality into the scan on the kernel side, and this is currently on the roadmap to build such functionality into the database, so that in the future we can do such scans much faster than we can do this in the current release. And there is still the restriction that in case you have an application system where a single column can contain multiple character sets, which happens. We know about such customers that had such configuration, where in different records may have data coming from different subsidiaries, and this is why they are encoded using pass-through scenario configuration, of course, using different character sets, real character sets, so not the one that is declared at the database level. For such situation, we don't have a solution now, because this is statistical analysis, so it will analyze the whole column and not each value separately. One of the problems with analyzing each value separately is, of course, that statistical analysis works well when the amount of data is large. If you look at a single value, which may be, I don't know, 10 characters or maybe less, or even 20 or something like this, then the probability of getting a good result is much lower than when you have a homogeneous data in the column in one character set. So this was one feature that we have added into 19.1 release of DMU. The second feature is the PLSQL code scan. So we use the PLScope functionality in the database to analyze the content of user PLSQL application code, provided it's not wrapped. And in this code, we point out various places that may cause an issue once the database has been migrated to Unicode. So, for example, if you have a local variable in PLSQL that is declared using a byte limit and not using the percent type attribute, then of course, if a column gets longer because of a cleansing action that you had to apply to fit the expanding data in Unicode conversion, then such variable, because it was hard coded to, let's say, 10 bytes or whatever, any other value, it won't grow by itself. If would it be declared with percent type, then making the column longer would make this variable longer as well. However, if it is not declared this way, then this is an issue, because if you read an expanded value to such variable, it will fail with the ORA 6502, I think is the error number, or something similar, that says that length is the length of the value is too high for the variable. So we point out such variables. We also point out various functions like substring B, subst B, that operates in bytes, because if you change the encoding, then the byte offsets, certainly if you go from single bytes to Unicode, then the byte offsets are no longer character offsets. You should not use such function. If you use function like CHR for character when you takes a numeric code of a character and returns the character. Of course, if you change the encoding from a single byte or whatever other database character set to Unicode, then the codes of certain characters may change as well, unless they are ASCII. And so in such case, we point out such functions as well to warn you that there may be a problem post-conversion and the application may not work as expected. So this is the second function. This is the second new feature that we have added to DMU 19.1.